Blood constantly rushes through your arteries, but when it reaches the tiny capillary beds to deliver oxygen, it has to slow down. During this physical delay, pressure pushes a clear fluid out through the porous vessel walls and into the microscopic empty spaces between your cells. This escaped liquid is called extracellular fluid. It bathes your tissues in essential nutrition and hormones, and as it washes over the cells, it sweeps away their metabolic waste products. This animated diagram shows a standard human circulatory loop over a 24-hour cycle. Your veins manage to absorb and return about 90% of this tissue fluid directly back to the heart. However, this creates a massive mathematical deficit. Every single day, 1 to 2 liters of vital plasma are left behind in your tissues. If that fluid stays trapped, the math turns deadly. The surrounding tissues rapidly swell, a medical condition called edema, while the bloodstream faces a rapid, life-threatening loss of circulating liquid volume. To manage this surplus, the body uses a delicate parallel network of tubes running alongside your veins. It collects that remaining 10%, now called lymph, and begins routing it back toward your heart. The human cardiovascular system depends on this secondary drainage network to maintain its own volume. Without this silent vacuum system constantly catching the overflow from nutrient delivery, your body would simultaneously swell and dehydrate. Moving that escaped fluid back up to the chest presents an immediate mechanical problem. The lymphatic system lacks a heart to pump it. Instead, it borrows momentum from your skeleton. As you walk, reach, and breathe, your contracting muscles and flexing joints physically compress these delicate internal tubes, squeezing the fluid upward against gravity. While most of this system acts as a vacuum for escaped water, the vessels lining your gastrointestinal tract have a highly specific alternate job. They absorb fats directly from the food you eat. Malfunctioning vessels in the gut lining can cause malnutrition. Because this system regulates how fats are handled, its failure is linked to the development of obesity through the disruption of fat and carbohydrate metabolism. Human movement serves a dual biological purpose. Every step you take acts as a manual engine that drains stagnant fluid out of your legs and forces vital dietary calories through your biology. As the lymph flows toward the neck, it must pass through thousands of bean-shaped checkpoints called lymph nodes, which are concentrated in the neck, armpits, and groin. Inside a lymph node, B cells cluster in outer germinal centers, and T cells group in the inner paracortex. Lymph percolates slowly through these cells, trapping foreign antigens before the cleaned liquid exits the other side. Beneath your stomach sits the spleen. It shares a similar physical structure with lymph nodes, but it pulls directly from the fast-moving bloodstream rather than the lymph. It divides its labor into 2 distinct zones. The white pulp generates new lymphocytes and antibodies to fight off infections, while the red pulp hunts down and eliminates old, damaged red blood cells. This network subjects every drop of fluid to a rigorous biological interrogation, ensuring no waste or infection reaches the heart. To run these thousands of checkpoints, your body must constantly manufacture millions of new T and B cells. That production happens in a distinct set of structures, known as the primary lymphoid organs. The ultimate biological factory is your bone marrow. It generates the initial stem cells for every lymphocyte and serves as the maturation site for B cells. Prospective T cells, however, leave the marrow early. They migrate to the thymus, a gland in your upper chest, just behind the sternum, to undergo specialized differentiation and growth. This graph charts human age on the horizontal axis against thymus mass on the vertical axis. There is a sharp peak during adolescence, followed by a steady, lifelong decline. Because the thymus actively deteriorates as we age, our T cell output falls in a parallel, permanent drop over time. Your adaptive immune response relies on a continuous manufacturing pipeline. It originates deep within your bones, but the central training facility for T cells operates on a strictly decaying timeline. After being scrubbed in the nodes, the purified lymph completes its one-way climb from your extremities up to the base of the neck. Here, the journey reaches its mechanical end. The lymphatic vessels open up, dumping the cleansed fluid directly into the large subclavian veins on either side of the neck. This final deposit reunites that missing 10% with your circulating blood plasma, restoring the critical volume that was lost at the capillary beds hours earlier. The entire network has a dual identity. It acts as the physical recycler of your macrofluids and the microscopic battlefield for your cellular defense. Without this invisible, unpowered set of tubes catching what the bloodstream leaves behind, our tissues would balloon with water,